This video, I will show you how to solve a radical equation. So, here are the steps to solving a radical equation. The first step is isolate the radical. So what I mean about isolate the radical is make sure the radical is on one side of the equation alone, on one side. For example, over here you have the square root of x equals 8. As you can see, this radical is on one side by itself. Now if we had something on the left side, for example minus 8 equals 0, then you need to isolate the radical by adding 8 to both sides, and that'll give you the square root of x equals 8. So that's the first step, just in case your radical is not on one side by itself. Now I gave you a very simple example right here of a radical equation that you could probably solve if you just think about it. What x value will work for this equation? So this is saying the square root of something equals 8. The square root of what equals 8? If you think about it long enough, you can figure out the answer. The square root of 64 equals 8. So that was just a simple radical equation that you can do in your head, but I'm going to show you how to solve the other radical equations. Now, me definitely emphasize, always check radical equations, because sometimes you end up with solutions that are called extraneous solutions, and those solutions actually do not work once you plug the answer back into the original equation. So for example, square root of 64, does that equal 8? All I did was plug in the answer back into x to see if the left hand side does equal the right hand side. So 8 equals 8. The left hand side does equal the right hand side. Therefore, x equals 64 is correct. Alright, let's move on to all of the steps. The first step, isolate radical. Second step, raise each equation to a power, and that will eliminate the radical. Solve for variable, check solutions. Let's look at A. The square root of 3x minus 2 equals 5. Since this is the square root symbol, in order to get rid of this symbol, you can square both sides. Okay? If you square both sides, that is the inverse of the square root symbol. So if we square both sides, squaring the square root is basically like canceling out this radical in this 2, because they are inverses of each other. It's like saying 1/2 times 2. 1/2 times 2 is 1, right? So all of that goes away, and you're left with just what's under the radical, 3x minus 2 equals, however on the right side, 5 squared, we can simplify that to 25. Now all we're doing is solving for the variable x. We will add 2 to both sides, and we get 3x, that cancels, equals 27. Divide by 3. X equals 9. However, what is that last step you always should remind yourself to check? So we're going to check when x equals 9, if we plug that back into the original. So the original is 3x minus 2, but we're saying that x equals 9. So I'm going to put 9 back in here to see if the left hand side equals the right hand side. So we have the square root of 3 times 9 is 27 minus 2. 27 minus 2 is 25. So the square root of 25 equals 5. The square root of 25 does equal 5. So the left hand side equals the right hand side. Therefore, x equals 9 is indeed your answer. Moving on to B. B is the square root of x plus 2 equals 6. Again, you should isolate your radical, because notice here we have a 2 on the side where the radical is. So the first thing you should do is isolate your radical. Get this by itself. We will subtract 2 from both sides. That way you have just square root of x on one side equals 4. Now you could probably solve this already in your head, but again, we're going to raise each side of the equation to a power. So when we square this side and square this side, again, this squaring of the square root symbol are inverses of each other. Knocks that out. We just have what's under the radical left. X equals 4 squared is 16. However, before we decide that that is definitely the solution, we need to plug that 16 back into the equation to see if this works out. The square root of 16 is definitely 4. Plus 2 equals 6. 4 plus 2 is 6. Therefore, x equals 16 is a solution to this equation. Next, we have c equals the square root of 4 minus x equals x minus 2. Again, we're going to square both sides. The radical was already on one side by itself. That way, you will just get 4 minus x equals x minus 2 squared. Now, there's no shortcut way of doing this. You have to write this out twice. Some students make the mistake of trying to do some type of shortcut method. There is no shortcut method when there's a binomial square. You have to write this out twice and FOIL it. Alright, so we have 4 minus x equals x times x is x squared. X times negative 2, negative 2x. Turn around, multiply negative 2 times everything over here. So that's negative 2x again, and negative 2 times negative 2 is positive 4. So what we have is 4 minus x equals x squared minus 4x plus 4. Now, of course, we're not done because we have not solved for x. But here, as you can see, we have an equation, and we have what looks to be something like a trinomial forming. So you always have to use your steps of solving an equation. And the first step is get everything on one side set equal to 0. So here, I'm going to move everything to the right side so I can subtract the 4 here, and that will cancel that out on both sides. And then I would turn around and add the x. That way we will get 0 on the left side, since all of that cancels, equals x squared minus 3x. Alright. The second step of solving equations is to factor. So we will factor out the GCF x, and we'll get x minus 3. And then we will set each factor to 0. So notice that in this case, we end up with 2 solutions. 2 solutions. We need to check both. Alright. So we're going to check 0 into our original equation first, and then we're going to check 3 into our original equation. So check when x equals 0 first. So the square root of 4 minus, let's plug in a 0, equals 0 minus 2. Here we have the square root of 4, and over here we have negative 2. Now the square root of 4 is 2. That does not equal negative 2. Therefore x equals 0 is a extraneous solution. It does not work, so we throw it out. Next, let's check when x equals 3. Plug in 3 into the original. 4 minus, we're saying that x equals 3, so we're going to place that x with a 3. Again, equal 3 minus 2. Therefore, we have 4 minus 3. So we have the square root of 1 equals 3 minus 2, which is 1. Square root of 1 is 1. It does equal 1. Therefore, x equals 3 is our only solution for this particular problem. And here, notice that our radical is not isolated, so we need to subtract 5 first. That way we get the cube root of x plus 1 equals negative 2. In this case, we have the cube root of something, so in order to get rid of the cube root of something, we need to cube it. And we're going to cube the right side as well, of course. Whatever you do to one side, you must do to the other. Now, cubing the cube root again are inverses, so gets rid of all of these radicals. We're only left with x plus 1 equals negative 2 times negative 2 times negative 2 is actually negative 8. And then all we have to do now is subtract 1 from both sides. And we get x equals negative 9. We're going to check, okay, the cube root of, we're going to plug in our negative 9 to see if the left side will actually equal the right side. So the cube root of negative 9 plus 1, cube root of negative 8, rewrite everything else, cube root of negative 8 is actually negative 2. Negative 2 plus 5 is actually 3, so that checks out. Let's do one more problem. I'm going to skip E and go all the way to F. F here looks like it is hard. However, it's probably one of the easiest problems, because first we want to get a radical on one side by itself, and now we have 2 here, as you can see. So if we can get one radical on one side and the other radical on the other side, it will be better. So I'm just going to add radical 5x plus 2 to both sides. That way all of that cancels out. And you're left with radical 7x minus 6 equals radical 5x plus 2. How do we get rid of these square root symbols? All we need to do is square both sides. Doing that, we'll get rid of the radicals, and we'll have 7x minus 6 equals 5x plus 2. And now all we have to do is get our like terms together and solve for x. So subtract 5x from both sides, we get 2x minus 6 equals 2. And then we'll turn around and add 6. We get 2x equals 8. Divide by 2. Alright, we're saying that x equals 4. What you do, again, you need to go back and check to make sure. 7 times 4 minus 6 minus 5 times 4 plus 2, does that equal 0? That's 28 minus 6. 20 plus 2 equals 0. 28 minus 6 is 22. Minus another radical 22. 0 equals 0. So it checks out.